This is Unit 5, Lesson 7, Solving One-Step Inequalities. We're going to start out with the discovery activity. We have a number of cases where we're going to start with an inequality. For each one, it's going to be the same one. 4 is less than 12. And I think we can all agree that 4 is in fact less than 12, so that's a true statement. What we're going to do is perform an operation on both sides. We're going to discover whether doing what we do keeps the inequality as a true statement. The very first one is written for you, so you can just look as we follow along. So we start with 4 is less than 12, and then we're going to add the same value to each side. Say we add plus 5 and plus 5. Simplifying, 4 plus 5 is 9, 12 plus 5 is 17. Is 9 less than 17? Yes, it is. So by adding something to each side, we still have a true inequality. So we'll know that. If we have an inequality, we add something to both sides, still going to remain the same. Still going to remain true. All right, case number 2. Now you're going to be writing here. Here we'd like to subtract the same value from each side. We're going to test out this case to see what happens. So say we subtract 1 from each side, minus 1 minus 1. That gives us 3 is less than 11. Is 3 less than 11? Yes, it is. So it's still a true statement. So our rule is that we can subtract the same value from each side of an inequality, and it's still going to remain a true statement. All right, let's try some multiplication. Here we're going to try a positive value. If I multiply each side by 3, then we're going to get 12 is less than 36. 12 is less than 36. So it turns out that multiplying by a positive value still keeps our inequality as a true statement. All right, case 4. This time we're going to try and multiply by a negative value. So what happens if we multiply each side by negative 3? When we do that, we get negative 12 is less than negative 36. That is not true. Negative 12 is greater than negative 36. So there's a problem here. If we multiply by a negative value, the inequality is no longer a true statement. So to keep it a true statement, we have to reverse the inequality symbol. So you can see if I rewrite it, negative 12, and I switch that inequality symbol to be the opposite direction, then we've got a true statement. So that's an important thing to know. Whenever we're working with inequalities, if we multiply both sides by a negative number, we've got to then also reverse the inequality symbol for it to remain a true statement. Let's try it with division. Let's divide each side by a positive value. Say we divide each side by 2. We would get 2 is less than 6. That is true. So dividing by a positive value still keeps our inequality to be a true statement. I'm sure you know what's going to come next. Let's divide each side by a negative value. Dividing each side by negative 2, we get negative 2 is less than negative 6. That's not true. Negative 2 is farther to the right than negative 6, so we know it's greater than negative 6. So that does not keep our inequality still being a true statement. So if we divide by a negative value on each side of an inequality, we must reverse that inequality symbol for it to remain a true statement. All right, so take a minute to think about what the general rule is. What do we need to do when adding, subtracting, multiplying, or dividing to keep our inequality a true statement? Well, the rule is if we're adding or subtracting, or multiplying by a positive or multiplying by a negative, we don't need to do anything. But when multiplying or dividing by a negative number, we must reverse the inequality symbol for it to remain a true statement. When multiplying or dividing by a negative number, we must reverse the inequality symbol for it to remain a true statement. So you need to write this down on your note sheet. If you need extra time, just pause the video and then start it again when you're finished writing. Now we're going to apply this information to solving an inequality that has a variable in it. Example 1 says, some number plus 7 is greater than or equal to 5. So we're going to proceed just like we would solving an equation. but keeping in mind our special rule about multiplying and dividing by negatives. So we want to get the x isolated, x by itself, and you can see that there's a 7 with it, a plus 7. So we're going to undo that plus 7 by subtracting 7, and then we have to do that to the other side as well. Now, when we think about the sign in our answer, we think about what did we just do? Well, we just subtracted. If we subtracted, it means we don't need to do anything, so we simply write what's left over on the left is x. We write the same inequality symbol, greater than or equal to, and then 5 minus 7 is negative 2. So there's our answer, and we can go ahead and graph that. X is greater than or equal to negative 2, closed circle on negative 2, line going to the right. Example 2. We want to do the same thing. We want to get x by itself. And what do we see with it? We see a negative 7, a minus 7, 7 being subtracted. So we're going to undo that by adding 7 on that side and then going ahead and adding it on the other side as well. So when we do our simplifying, we have to think about, what did I just do? We just added. Adding to both sides doesn't mean you need to do anything special with our sign. So negative 3 plus 7 is 4 is less than x. Now, if you recall, we want to rewrite it. Now, this is not reversing the symbol. This is rewriting our entire inequality as a mirror image. So I'm going to write it with the x on the left and the 4 on the right, and then mirror image that symbol so that it really stays in the same relationship to the x and the 4. X is greater than 4. We can go ahead and graph that with an open circle at 4 and our line going to the right. Example 3, here we have a negative 2 being multiplied by the x, so we want to undo a multiplied negative 2 by dividing that side by negative 2 and then dividing the other side by negative 2 as well. Now, here's where we have to really pay attention. What we've just done is divide each side by a negative number, and if that's the case, then it means when we simplify, we have to reverse that inequality symbol. So we initially had a greater than, we have to switch it to a less than so that it stays a true statement. So x is any number less than negative 5. We can go ahead and graph that on our number line as well. Example 4. 6x is less than or equal to negative 18. Here we've got a 6 times the x, so we want to undo that by dividing by 6. So we undo by dividing each side by 6. And now here we're paying attention to what it is that we did. We are dividing by a positive number. So it doesn't matter that that 18 is negative. That has no bearing on what we do. We're only paying attention to exactly the thing that we were doing to both sides. And what we're doing to both sides is dividing by a positive number, so that means we don't change anything. So we're left with x is less than or equal to negative 3. We keep that inequality symbol going in the same direction. There is our graph. Example 5. Here we've got x divided by 2, so we want to multiply each side by 2. Again, we pay attention to what exactly we're doing. We're multiplying by a positive number, so that means nothing happens to our symbol. So we do our simplification. Negative 6 is greater than or equal to x. Didn't change that symbol at all. But now we're going to rewrite the whole thing mirror image. So we take everything and we swap it around. We mirror image x from the right to the left, negative 6 from the left to the right, and we mirror image our inequality symbol so that it's still sort of pointing toward that x. And there is our graph. Example 6. X divided by 3, except that's a negative value, so we are going to want to multiply each side by a negative 3, so we can have negative times negative makes positive. When we do that, we have to pay attention to the fact that we're multiplying by a negative 3. That means we're going to have to reverse that inequality symbol so that it stays a true statement. When we simplify, we get x on the left and 15 on the right, and we go from greater than, reverse it to less than. X is less than 15. There's our graph. All right, example 7, you give it a try. We're going to add 5 to each side. That gives us x is less than or equal to 4. There's our graph. Example 8. we're going to multiply each side by -3. When we do that, it's important to remember multiplying by a negative means we're going to reverse the inequality symbol. X is less than -15. Example 9. We're going to subtract 8 from each side. Here, don't be fooled by the fact that it looks like a -8. We're subtracting 8 from each side. And if you remember, when we subtract, we're not going to change anything. Only when we multiply or divide by a negative number do we switch that inequality symbol. So we get 12 and we keep it greater than or equal to x. Now I'm going to mirror image the whole thing, so my x is on the left, x is less than or equal to 12. Example 10, we're going to divide each side by -8. We are dividing by a positive, so we don't change our symbol. X is greater than or equal to -4. There's our graph. In example 11, we're going to divide each side by -5. Here's where we've got to pay attention. Hey, that -5 division means we're going to reverse that inequality symbol. So 4 is less than x. I'm going to mirror image the whole thing to make it easier to graph. X is greater than 4. That's it. Put your note sheet in your binder. I'll see you tomorrow.